We're on page 21. I think you're going to dig this. This is very visual as opposed to all the mathy that we've been doing. Do you agree that this integral from A to B just represents the area from A to B? We've seen that. We down with that? What about this one here? From A to B, why is A's area negative here? Why? It's below. Exactly. What about big B's area? Is above, so they said plus, and then big C? Why would they use little a, little c, little b, and big A, big B, big C? I just wish that they would have used different letters. You know what I'm saying? We got 26 letters to choose, and that's what you got? Okay, question. This is what we really got to hit today. Do you agree that we could take the area from little a to little b? Don't you agree that's this here? Little a to little b, and that would be this area. No, my bad. Little a to little b. My bad. Let's back this up. I'm going to start here. The area from little a to little c is this, correct? Yeah. What about the area from little c to big B? Little c to little b, wouldn't that be this and that? Yes. Could we say, when I put all those together, that's really just the area from A to B? Yes. Yeah, you can chunk those little areas out however we want. Sound good? So now, what happens if I look at this and they change my bounds instead of from A to B, instead of from left to right, they now went from B to A, from right to left. Negative. It's just going to be negative. So you guys, all that we got to think about is if anytime they give you this, anytime they give you any interval, you can always flip those bounds and your answer will just be negative. There it is. Okay, you can always do that. Do you have to do it? No. Are they always equivalent? Yes. You can flip the bounds, make it negative, you're good to go. When we go backwards, it's going to be negative. Let's look at just a couple rules. So if we had from B to A, what could I say that that's going to be equal to? Exactly the opposite, and then from A to B. We don't have to do it. A lot of kids are like, I have to flip the bounds. You don't have to, but it's just important to know they are equivalent. Guys, what happens if I say, hey, go find the area from A to A? Zero. Anytime those bounds match, always going to be 0. Well done. What if I've got a constant right here? That constant, you can just pull it out front, you guys. You would just say, all right, I'm going to go find the area, and then it'd multiply by that constant at the end. What if that constant was a -1? Sure. Just pull out that negative out front. It's just a constant. This one's saying, hey, if I've got the area of an F graph from A to B and the area of a G graph from A to B, we could separate them out and you could just worry about them one at a time. You could say, I'm just going to focus on F, and then I'm just going to focus on G, and then I could add those up at the end, if that helps you just breaking them apart. And then I want to show you this last guy, how we can visualize this one. This is saying, hey, if we've got an area from A to B, let's go say I've got some graph and I've got some area from A to B, and I'm going to be like, ooh, that looks like that. And then I've got some area from B to C. Could that look like that? How could I put these two areas in one integral? Exactly. That integral could just be, oh, I could add those up and just say from A to C. You can break them apart or you can put them together. Up to you. Okay. You guys, what if they give us this info? They say this is some info about the area of F graph. This is also info about an area of an F graph. Then they change it to area of a G graph and more info about a G graph. Look at what this first question says. It says, what's the area from 2 to 8 of an F graph? You're like, what?
15.
It is 15. How did you think of that, Greer?
Added 96.
A way to think about this, do you guys agree the area from 2 to 5, he's saying if I had to go from 2 to 5, and they're saying that that area was 6, and then from 5 to 8, they're saying that area was 9, can I then say, oh, then the area from 2 to 8 would be the 6 plus 9 to get us 15? Are we okay with that? Do you need to show me any work on these problems? No. If you like that visual, go for it. Sound good?
Yep.
What about from 2 to 5 of f minus g?
3.
No,
That's
6 plus 3, right?
there you go. How'd you do that, Lila?
Because the G, it's negative because the bound of this.
They were ornery. And Stevie, they're going to do this on every single one of these questions. They're going to make you flip a bound somewhere. Now, do we have to flip it? No, but we would have to think, oh, it'd be minus that quantity. So, again, what I like to do personally, you don't have to, but as soon as I see those, I flip it myself and I say, then that would be a positive 3 or negative 3. Exactly. I kind of write that out as soon as I see it so I can refer back to that. Then they're saying, what's the area from 2 to 5 of f? You agree that that was 6. Then we have to do that symbol minus, and then we'd have to use that negated. They were tricky. Good job, Lila. Good eye. Can't get anything past you. This is that constant. That constant, we can just say, oh, that's the same as 3 times the integral of 5 to 8. Did they give us from 5 to 8?
27.
Yeah, they gave us from 5 to 8 of f right there. Is that 9? So 3 times that 9 is 27. This is a little harder. 5 to 8. Oh, G. We're only focusing on the G's.
Do you do 10 minus the
10 minus 2.
do the 2 to 8 minus the 2 to 5?
So let's think about this. If we're talking we have info on 2 to 5, and we have info on, 2 to 8, don't we? So you're saying 2 to 8 is this whole 10, right? 2 to 8 is the whole 10. 2 to 5 is 3. So it's going to be, 2 to 5. 2 to 5 is what? Negative 3. Even though I drew it above, I'm just going to say negative 3, okay? So how would I figure out what's left?
10 minus negative.
Very good. 10 minus the negative 3 is going to get me. Great. I am a visual person. I do like drawing it that way because I think it helps see. I'm going to show you another way too. Another way we could have thought about this, you guys. Could I say that if I were to do an area from 2 to 5 and an area from 5 to 8, you okay, Nels?
Yep.
That would get me an area from 2 to 8. Does that kind of pick up where it left off 2 to 5? And the area from 5 to 8 would get me that whole area.
Yeah.
Then we could kind of plug in what we know. We know 2 to 5 is negative 3. And we know 8 to 5 to 8 is what we're looking for. And we know 2 to 8 is 10. This is just another way to get that 13. How many people are more of a draw the humps kind of visual person? How many people are draw the integral? Go back to this one. How many people are this one? Okay.
Yeah.
All right, let's see. I'm going to skip that next one. Yeah, here we go. Whoo! Whew! Okay, here goes an AP question. We're going right into it. They want to know what the area from negative 10 to 6 is. Which one do we want to flip? The first one. You're saying, okay, hold up. The area of this guy is really negative 10 to 4. It's going to get me what? 3. I agree. So let's think. If I went from negative 10 to 4, and we're saying that that area is 3, and then they also gave us that 4 to 6 is 5. What are we going to get? 5 plus 3 is 8. Are they ready for you to say 5 minus 3 is 2? And forget to flip it. You know what I'm saying? They're ready for you to do that. Whew, here's another AP. I promise you, they're going to give you one question like this. One question. Will they make you flip their bounds? Yup. Where might we need to flip the bounds? Right there. Yep. They're making you do it right over there. And I'd say, from 3 to 7, the value is 32. So let's visualize this. What do they want?
1 to 3.
1 to 3. They want 1 to 3.
So 42 minus 13.
Okay, so you're like, okay, well, if I were to look at 1 to 7 is 42. And then 3 to 7 is 32. How am I going to get this? Now, this is I almost said a bad word actually, because I'm so mad at AP for this question. It's not 10.
Why?
It's 20.
It's 20. Why is it 20?
Oh, because
Because there's a coefficient.
Isn't that so annoying? Like, you've just done all that. You knew that calculus, and they're really going to do that to you? I almost said a bad word because I just think that's ridiculous. It's literally one coefficient. And they didn't even put it in front of the integral. You know what I mean? That's so rude. So I hate that. That's why I put it on your notes and not your homework. I hope that they don't do that to you because that's crap. Okay. This one, ugh. I put this on your notes and said your homework for a reason as well. They gave us an area of F. I'm going to say this one's F, which is 21. Then they gave us some info about G. Then they gave us some info of them together. And they want to know what's them together from 0 to 3. What? You're a visual person. I'm a visual person. Would you say, Care Bear?
And they also put the 1/2.
And there's a half C in there. Is this, let's say pay attention to that right now. Is that the same as 1/2, 0 to 10 of G of X? Yeah, I think that's important to remember that we can pull that constant out front. And you agree, what they want does not involve a 1/2 of that integral.
Can't you just multiply by 2?
Multiply by 2. We want to get rid of it. Well done, Greer. We would get rid of that. So we'd say, okay, from 0 to 10,
16.
it's just going to get me 16. Well done. So I'm going to draw zeros and 10s and 3s, but without an F and a G. Let's just picture something real fast. From 0 to 10. If I've got 0 to 10, because they gave us 0 to 10 now for F and G, right? And then if I've got 3 to 10, how would I find 0 to 3? Yeah, so we want to do 0 to 10 minus 3 to 10, right? That's going to get me 0 to 3. To your point, Steve, you're like, hold up. We got to do F minus G, right? Do we know 0 to 10 of F minus G? Yeah, what would that get us? Yeah, we could just say, all right, 0 to 10 of F is 21. 0 to 10 of G is 16. Subtract them. 21 minus 16 gets me 5. Did they give us this info? Yeah. 3 to 10, they already put it together, of F minus G is 2. So it's 3. Oh, you guys, when they say this, what do they want given this graph? Say it again, Sammy. They just want the area from -4 to 7. That's a lot of shapes, so we can do this. What do we want to break this into? What are we thinking this guy over here is? A little triangle. Area of a triangle is just 1/2. Its base times its height. What's its base and its height? 2, 2. Love it. Then what do we have?
Semicircle.
Semicircle, positive or negative?
Negative.
Negative because it's below. I love it. Anyone remember the area of a semicircle?
1/2 squared over 2.
Pi r squared over 2. Love that. What's my radius there? Beautiful. You guys, is this triangle going to be the same as the first one we did? Base is 2, height is 2. So are you cool if I just say, I've got 2 of these guys?
So the half cancels.
The half will cancel. That's just me doing that instead of writing it again. Then we've got this ditty over here.
The trapezoid in a semicircle.
Wait, why a trapezoid? Couldn't it just be a rectangle? Because we're going to 7?
You just make two triangles
What about
because
the
they're the same triangle.
Wait, we already took care of that. This triangle is there.
Just do the semicircle.
Exactly.
So don't we have
Just make a square and a semicircle.
Radius
a
is
rectangle and a
1.
semicircle?
Pi.
Yeah, my semicircle,
It's just pi.
pi r squared over 2. Yep, because it's semi. Bless you. And we're adding to that a rectangle, which is what times what?
9 times.
Perfect. We got to cancel some things out. As Greer said, 2 times a half will cancel out. I'm left with an area of 4 over here. Over here, how many pies?
4 pi. Or 2 pi.
2 pi.
Or it'd be 3 pi.
No, 2, yeah.
2 squares 4 divided by 2.
I was thinking of it.
This guy plus pi over 2. Well done.
6.
Plus 6. So we're digging the 6 plus the 10. We're digging the 10s, aren't we? 6 plus 4?
I like B.
You like B? You like totals?
Yeah.
10, and then 2 minus a half would get me -1.5. Love it.